Another day to live, another day to love, and another day to love. For today's video, we're going to talk about our lesson number 1 for grade 9, which is the quadratic equation. In this lesson, you are expected to define quadratic equations, discuss the methods of solving a quadratic equation, solve quadratic equations using the following methods: extracting square roots, factoring, completing the square, and quadratic formula. When you were in grade 8, you were introduced to linear equations and functions. You found out how these concepts would be used to model and solve real-life situations. This time, you will discover a new equation that could also help you solve more real-life problems that is in a form of quadratic equation. Let us begin by answering the anticipation reaction guide. You will be shown statements related to quadratic equations. Your task is to fill in the anticipation column by writing the letter A if you agree with this statement and letter D if you disagree with this statement. Number 1. An equation of the form 0 is equal to ax plus by plus c is a quadratic equation. Agree or disagree? Number 2. The standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a, b, and c can be any real number. Number 3. All quadratic equations can be solved through factoring method. 4. In solving quadratic equations using completing the square method, there is a need to write the equation in standard form. Number 5. The roots of a quadratic equation will always be real numbers. Number 6. The completing the square method and the quadratic formula are used to solve quadratic equations which are not factorable. Number 7. The discriminant tells us the nature of the roots. Number 8. Imaginary numbers are possible roots of a certain quadratic equation. Number 9. The roots of a quadratic equation will always be distinct numbers. And number 10. In solving problems involving quadratic equations, it is possible to have one of the roots to be considered as extraneous. There is no wrong answer since I only asked for your thoughts and ideas for our lesson. Let us now explore quadratic equation and discover if your answers for the above activity are correct. Quadratic equation. It is a second-degree equation that is the highest exponent of a term is raised to the second power. Remember, the second power. The general or standard form of a quadratic equation can be expressed as ax squared plus bx plus c is equal to 0, where a is constant except for 0, b and c are any constant including 0, and x is a variable. Examples are given as follows. An equation is said to be complete when one term of the unknown is raised to the second power, one term of the unknown is raised to the first power, and one term with no unknown quantity. Example is we have x squared plus 14x plus 33. Also, an incomplete quadratic equation is an equation in which the term containing the first power of the unknown is missing. Example is we have x squared minus 81, in which bx is missing. For the characteristics of quadratic equation, always remember the standard form of ax squared plus bx plus c is equal to 0. It says here that the highest degree of the exponent is 2. And of course, it composed of 3 terms. We have the ax squared, which is referred to quadratic term. We have the bx, which is the linear term. And of course, we have the c, or the constant term. Remember the difference between a linear equation and a quadratic equation. In addition, linear equation is the highest degree of the exponent is 1, while in quadratic equation, the highest degree of the exponent is 2. Let's have an example. Simplify and identify which of the following is a quadratic equation. If the equation is quadratic, transform it into the standard form. So we have number 1, x squared minus 2x plus 1 is equal to 0. And that is a quadratic. The first equation is a quadratic equation because the highest degree of the exponent is 2. As you can see, x squared. It is the standard form is the equation itself. For number 2, we have 2z plus 5z is equal to 0. We know that 2z and 5z have the same variable. So we simply add those terms. So 2z plus 5z is equal to 7z is equal to 0. But still, that is not a quadratic equation. Why? It is because the highest degree of the exponent is only 1, and that is for linear equation. And for number 3, we have 8y plus 10 is equal to negative 4y squared. And arrange, of course, the quadratic equation. We have the 4y squared plus 8y minus 10 is equal to 0. So again, this is a quadratic equation because the highest degree of the exponent is 2. Now, let's work this out. Below are different equations used. These equations to answer the questions that follows. For number 1, which of the given equations is linear? Number 2, how do you describe linear equations? Number 3, which of the given equations is not linear and why? And for number 4, how are these equations different from the linear equations? What common characteristics do these equations share? So that would be the end of our discussion for the introduction of quadratic equation.